Welcome to everyone. Today we're having the voice of SCADAC, and if you are for the first time watching this record, Scientist Adoption Academy is a platform that used to research collaboration. So it's work as a tool to manage your work and to have all your projects in one place. And it has the functionalities of the storing, discussion, blogs, and uploading the files, and even doing the conference videos, which is to be in the coming version of the website. At the same time, you can meet your colleagues that they share with you the same ideas, or you can propose to have some even students working on similar topics as a part of their academic degree. In addition to this, if you are coming from a research group, that you can move all your discussions and all of your gadgets into one place. So Scientist Adoption Academy, scadacademy.com. We are working on to have an academic-based website that serve you for the most of your usage with interaction with your colleagues. So today, and before we start with the presentation and the training session, actually by Dr. Ali Aydda, I would like to mention the new update that it's as in our roadmap for the development of the website. Now I will just share with you the recent update that just I received from the company, that in a few days maybe we will have the publication part for each of members, and this publication part it will be connected to your Google Scholar. So when you have your profile, and this is the old version of, because it's just a staging website, we are testing our tools. So you will have the space that you are asking to add your Google Scholar link. So once you add it, you will receive the list automatically, all your list of publication up to 20 publication, and we start from the recent one. So the first one is the most recent article coming to the 20, and then you will have the more button. This is the more that in case if somebody want to see all your publication, you will access from here. Okay, so this is the default page of the Google Scholar, and this is like a preview of your profile. So later on, when you want to work with any of our members, instead of looking to the profile, now you have more evidences or more information about this member in case that you are looking for some common research article that you want to work on. So I believe this update, most of you was looking for it and requesting us to add it, and now it will be, as I said, maybe within the next week it will be mounted live on the website. So this is for the update, and I think we use the time. We have like 40 minutes that we can start with Dr. Ali. So as you mentioned, Dr. Ali is an assistant professor from Morocco, and today he will introduce to us the Landuse Landcover analysis using the optical images. So I will leave the floor for him, so he will introduce more and give more insight about this application, and we will follow up him for the next 30 or 35 minutes. In case you have questions or some issues about how to manage this application by yourself, you can reach Dr. Ali through the SCADAC, through his profile, sending message, or if you want the quick answer now, here also we have the messages that you can just drop us a message in the chat area. So up to this, I don't want to spend more time. So Ali, the floor is yours. Go ahead.
Thank you, Dr. Amar.
Okay.
And thank you for the novelty in SCADAC Academy about the Google Scholar and publication linked directly to SCADAC Academy. First, the objective of this presentation is to show you how to use ENVI in creating land use and land cover map using optical data. Did I active the sharing?
No. That's what I'm asking you. So if you like, you can share your screen. Then we.
Okay, to show you the platform of the used software is in.
Yeah, you can share your. No problem.
It's here now?
Yes, very good.
It's clear now, the software, Doctor?
Yes.
This is the software ENVI. I have the version 5.1, but there are different versions. This is a part of vision. This is a part of layer. Here is this the main menu of the software. There is a part of main menu also. This part is toolbox. When you searching something, you can type here. Before that, I will share with you how we can download, for example, optical data. In this session, we will use Landsat data. There are many sites. For example, Earth Explorer of USGS. There are Earth data, other sites of NASA also. There are Glowfish site. You can also download data from this site. You can download also from this site other Earth data NASA. I will share this link with you. Just I wanna download data from this site, Earth Explorer, USGS. How can I download data? Just this is the map of the world, but before starting download any data, you should register first. I'm gonna enter by my login. But if you're not registered, you should register, create a new account. Here is, for example, I will select study area of Agadir. Just zoom out. This is the study area. First, I clear the point that I selected first. Clear coordinate. For example, I'm gonna directly to my study area. For example, this point. Just creating here a polygon, which indicating your interest area to be download. After that, go through data sheet and select just only Landsat archive. There are many data. There are rather but Sentinel-1 or Sentinel-2, but all of them is not free. For Landsat are free, but in a level 1, level 2 is dependent demand of person interested to collect this data. Might take 48 hours to be received the demanded data. We're gonna collecting just only Landsat collection level 1. I'm trying to collect Landsat 8, and I will show result. For example, we have this data. The recent one is 12/12/2021. This is the data. I can collect it. I can download easy from. I'm selecting this image selected, and then download. Download. You should download the file with height capacity. Okay, and download. I already download the images. So this is the step of collecting data. Go back and log out. Same thing for the other site. About ENVI, as I said, this is the platform. I have already the data here. This is the data. The data collecting here is Landsat update 2017 10 30. Each data is images and metadata file, MTL. As you know, only we have maybe 12 bands. I will open the file using the data using the file open as, or using just not open icon in this bars. I'm going through to my data in my desktop. It's not raw. SCADAC training. This is the data, and I'm playing just only metadata. The last one, the metadata, not band by band, but when you open metadata, you will open all images you have. This is the image for the study area of the collected area. The essential step in land use and land cover mapping is to correct the error in images. As you know, all images in level 1 TP, I guess all open and free satellite data are now with level 1 TP, which means level 1 is that these images are already geometrically collected. So we will not need to correct the geometric error. But the atmospheric error is necessary to correct it if you want to, especially if you need to classify and to monitor land use and land cover or change during time. First step is to correct the atmospheric error. By that, first go to radiometric calibration. Maybe use this part, or maybe type in here radiometric calibration, or search in here. This is radiometric correction. Go through radiometric calibration is maybe this step, radiometric calibration. One click. You should select the multispectral band, not panchromatic band, non-thermal band. Reason that the thermal band you have other correction. We use multispectral band. If you interest is to minimize the size of your study area, just do spatial subset. For the reason to avoid the consuming time and all, I will minimize the size of this area by selecting here or by using subset by file. If you have already a region of interest, you can use it subset by file OBI or beyond using just this creating triangle. I will use okay. The attention with spectral subset will be 7 band, for the reason that are band in these multispectral bands. There are, before starting radiometric calibration, there are different or 3 in ENVI. There are 3 atmospheric algorithms to correct the atmospheric errors. There are FLAASH, fast line of side atmospheric analysis, spectral hypercube, and there are other object subtraction, and there are other. One is quick atmospheric correction. We started with FLAASH, which is the hardest one. Before starting, you should click in Apply FLAASH setting because we gonna using the FLAASH algorithm. So let it radiance. Pay attention with the output until leave will be Bill. Is one of format of images to be used in next step, and output when you are interested to save the result. I will save it here. I wanna name it radio calibration. Just abbreviation, you can call it what you want. And then okay. I'm gonna take a few minutes or a few seconds. This is the result. You see a difference between an original image and radio calibrated image. So now I'm gonna try to correct atmospherically using FLAASH algorithm. This is FLAASH. The FLAASH algorithm asking to input radiance image, which is a result of calibration. Input image is a radio calibration image. Spatial site, I will use all images because I'm already subsited before starting radiometric calibration. You use SCAL, no, let it 0.1. Output reflectance should change the output reflectance because it will take you directly to template when you have, but you should save it in your file of work. SCADAC training. I will save it here and I will name it the reflectance. Output FLAASH directory, same thing. You should select the file where you are working in my desktop. SCADAC training. I will put OK. Herein you should root name, just you should name it FLAASH or something else. Tip sensor type is multispectral, is OD, Landsat OD. Where is it? About flight date and about flight time, you should go back to metadata file. Go back to file when you started to the file of that you downloaded from Earth Explorer. You're gonna open it. You will see the sensor date, accurate date. This is the accurate date, or this is the time of acquisition. This is data accurate and science center time. For me is 30 October 2017 for time. You should mention that in here. As I said, October, not August, October 30 and 2017. Time of flight is 11:01. And 01. Here, this is the model at tropical. Here, maybe change it to tropospherical, and then multispectral setting. You can change just ground elevation, but it's not more interest. Multispectral setting. Here you should change just the Kaufman-Tern aerosol retrieval. Default, you can use the first one, okay, or you can use the second one. But we are not recent interested over water retrieval, but we standard using standard of land retrieval, because we will working in land spaces in not water spaces. Just default like that. Automatically, the filter function is already connected with the file of filter function in classic ENVI. So automatically we did OK, and then apply. That's gonna take a few minutes, 1 or 2 minutes.
So, Ali, now the steps that it's followed. Sorry. Okay, I leave it. Very nice. Let me just quickly ask about now the steps for the radiometric correction that you did it first, because for the atmospheric you should have the radiometric first done, then the atmospheric should be followed.
Yes.
So it's kind of mandatory logically and by the software as well.
Mandatory.
Yes.
Because
yes.
Why? Because the algorithms, as you know, we use just optical data. We use just the reflectance data.
Correct.
As you know, the sensor optical is just working with the emitted or bien retrodiffused or bien reflected light from from objects on Earth surface by which is clearly source of energy is from sun.
So then about the other settings that you applied, they are like by recommended, or that is because of the experience that you followed, or it's based on some work carried before? That kind of
because it's kind of literature, just that they mentioned that Flash is the hardest one and the performance one, but is not 100%. I'm not so sure I agree with the literature. There is a kind of some references said that other algorithms is better than other algorithms, but without using the same area and same study area. Or if I change the study area, will be give another thing.
What about if we have some objects between the sensor and the ground? If we have some clouds, or if we have dust storm, or we have, do we need to add one or more filters before we are getting the correction, or this can be carried later?
About the cloud optical data, you can't see it anything about the cloud.
Okay, well,
But radar you can see. As you know,
yeah.
radar using micro and waves, microwaves, but optical using just visible and infrared.
What about if you have like let's say dust or like some fogs, or is there
Thus,
anything?
thus you can extract it using the FLAASH atmospheric algorithm.
Mhm. Okay.
As you see here, a
Yeah,
Eurosol model,
Russell.
that's is
Correct.
one of topic to use it to eliminate the pixel that affected by aerosol.
Very nice. What I wanted to highlight here, that the process is carried now by Dr. Ali, is not just applying the software. It's not like about just following a certain procedure. He optimized the selection of the algorithm based on the literature that he followed, and this is what the uniqueness of doing the application of today. Because I think there are too many also tutorials dealing with the correction and using the ENVI, because the software was there almost more than maybe 20 years, or more than this. So, but today, Dr. Ali, he wanted to mention something based on his experience of using the tool. So, if you have any questions, or please feel free to contact him in this one. Sorry, Ali. Yeah. Go ahead.
Oh, no problem. This is the result of Flash algorithms. It is. You can open it. You can see it because it is not open directly after the processing. You can open it from this data manager. Go through to the end of the result. Here is the flash or the reflectance flash, the result of the map that obtained after atmospheric correction using flash. You should select that in read band, green in green, and blue in blue. Load data to see the data, the result, the final result of flash. This is the final result of flash. If you compare the reflectance or spectral profile, for example, this is there are a mistake here. Why? Because the data I will show you one. If we compare it with the original data or the reflectance data, the spectral here, and the radio calibration here. You see that the difference of signature spectral. The problem with Flash is that they compute all. We see the statistic here, statistic filtering here until box statistic to see the statistic of the images received by Flash algorithm, statistic, and computing statistic view, compute statistic here, reflectance Flash. Just give me spectral subset. I will select all bands. Select all. See the statistic for all bands. histogram and basic statistic. You see here that the minimum is a negative. Or there is band 6 for me is all data is 0. For this reason, and is not continue to be show the other result. Okay, that is clear. So we should minimize that the minimal to 0. Okay, the maximal should be varying between 1 and 0. 0, 1, and just 1, not maximum 100 or 1,000.
You mean you will normalize the?
Yes, yes, yes. Normalize the statistic.
Okay.
Received by FLAASH. And also to avoid the error adapted to reflectance with signature spectrum. So to do that, there is in literature an equation should be used easily in ENVI to complete the FLAASH algorithm collection. Go through band ratio here and use band math, band ratio and band math, and pass here and add to list, and then select this one and okay. And they're asking for what? They're asking for the bands. This equation, to explain this equation, what is mean? Just to is the band which each one or two or three that is less or equal 0, greater or equal 10,000, greater than 0, less than 10,000. Just a question made by some references in literature. It's easy to resolve this problem of maximal and minimal statistical in FLAASH results. And then map variable to input file. The input file is a reflectance file or FLAASH that you have. Spectra subset listed 6 because this 6 one, the 6 one is our result are 0 for me. If you haven't 0 in the result, you should add it all bands. This is the result. Go through to choose the file when you want to register the data, to save the data. I name it FLAASH final. And then okay. This is the result. You see the difference here. Compare it with the first one. You see the difference.
The energy is higher now.
The energy highs. If you're gonna show the spectral reflectance in this point, is different the first time.
Correct.
The first time is not attend this point. Just the maximum is for reflectance of wavelength is 1. If we compare it with the first one, this is difference. You can see that. We saving this. You see that the difference, same point. You see the difference. Wavelength is not achieving the whole bands because there are an error in band 6 for me. Maybe you will not receive these problems, but the area is given this problem. This is difference. This is the result of FLAASH. The band now are corrected. Also, the data value is varying between 0 and 1. Here, the data value is varying between 0 or maximum to 2,000 and more. So for
Please.
FLAASH. This for FLAASH. The images now is corrected atmospherically. There are the easiest one. There are other algorithm is dark object subtraction. Dark object subtraction is not complicated like FLAASH. Some literature recommended us than other algorithm. You should first to use radiometric calibration, multispectral band also. Spatial subsite, I will use the subsite by file like I use it for FLAASH also. And then, okay, is here you should mention reflectance, not radiance, because FLAASH need radiance as input data, but DOS need reflectance. Okay, not selecting anything here, not changing anything. If you applying FLAASH setting, dot all information will be changed, and then select the file where you want to save the result. I will mention that as DOS calibration radio reflectance for DOS. Here is the result. That is the reflectance for DOS. Now apply DOS is dark object subtraction in radiometric calibration, or just type in here dark. It's not a problem to do that. Dark will give you dark subtraction, but I will use the manual here. Dark subtraction here, and then reflectance DOS. Don't perturbate that by the radio calibration. Use it for FLAASH, but reflectance for DOS. Selecting all spectral bands minimum and choose that the file we want to save the result, and then I will name it DOS. Okay. And this is the result. Someone wanna tell me why this is red? Just because the selection of band here near in infrared and green in the red and blue in green. As you know, near infrared usually used in mapping vegetation, all but red here is vegetation. So this is the result of DOS. We can compare the DOS, also the result here, complete statistic.
Yes.
Statistic. For DOS, and show the result. The minimum is 0 in beginning. I have any problem with those algorithms is okay. Also the signature spectral is clear, not like flashing in first step. So this is the step one. You can use DOS or you can use FLAASH.
FLAASH.
Okay. As you want. It's easy to use it both.
Yes.
But I recommend to use FLAASH, which is the easiest one, and not recommend anything else. This is the first step, is atmospheric correction. The second step is the extraction of the component or the primitive. The component will be used as input data for classification, or are essential for classification. If you gonna directly to classify in brute image after atmospheric, we will give you nothing. But you should extract the primitive or the component. There are many technique of transformation. Maybe that spectral indices like NDVE like combining NDVE and NDVE, master normally different index, and other which you're working with urban area. You can use built-up index and combine all these band or three bands as a result to create your classification of land use and land cover. May there are too many others technique of transformation. There are the correlation stretch, Taslit tap, about colors. There are principal component analysis. There are MNF, which usually and always used in geological mapping. There are independent component analysis. But go back to literature, the most one used in classification is the principal component analysis. But you can test other ones as you like. I'm gonna start with declaration to show the difference between principal components and the declaration stretch. Declaration stretch is that use just three bands as you want, just using three bands, but principal component analysis using all bands. Yes, you have seven bands, but you gonna reduce the noise in bands in just one in first one. I wanna show you the statistic of the principal component analysis of the principal component result to show you what is the difference. I'm gonna start with the correction series. I'm using dark object subtraction result image obtained after correction by dark, or you can use flash. For me, I'm gonna use in dark. I'm gonna select just blue and green and red bands, and then already is subsided, not necessary to use it, and then choose the file when you gonna save the results, and name it declaration stage, doc, and name it what you want. Here is the result, and you're gonna see that the vegetation here is green. Some perturbation between soil and urban area. Also, the green here in coastal area, which is not correct, because here there is no vegetation, but is the wave here. If we compare it with the principal component analysis, you should go to principal component analysis and forward PC rotation a new statistic, which means is creating a new component. And also I'm gonna selecting those result, which means is the band corrected by dark object subtraction, and selecting all bands. Okay, pay attention with all bands because you have 7 bands. Spatial subset are false in because already subset the area. And then principal component analysis. You can for those bands, no problem. You can name it what you want. Principal component analysis, and it's the same name, no problem. And don't forget to go to strict to the folder when you save the result. Here, number of output band, let it 7 to show you what is the difference between first component and the other component. And then this is the result. This is the result. This is the result. PC igni value each band are principal component all as a 7 band. There are. You can see that in data manager here. Go to the end. This is the principal component. You have band 1, band 2, band 3, band 4, 7 bands. Okay. But I want to see the statistic. Okay, before statistic, statistic. Not compute statistic, because principal components give you statistic, a result of statistic, view statistic. A view statistic, going through to your folder when you save the result. SCADAC training. This is the principal component analyze the statistic of PCA. Open. This is the result. You have the plot of each band of each component. You have basic statistic. You have a covariance. You have correlation between band. You have eigenvalue or eigenvector. And here you have eigenvalue. Eigenvalue, which means that the first band, which is the first component, contain, if you convert that the value here in percentage, we're gonna give you that the first one contain all information, and the second one contain all information, and maybe the third one, but the first one contain all information in, as you know, principal component or other reduce the data in first, just to reduce the data in one component. I'm gonna select in just the 1 and 2 and 3 bands. Okay, and this is the result. Now, if we compare it with the decoration street, this is the difference. Here, the study area where you have the water area where matter, suspended matter here is more, is not calculated as vegetation. It's different now, as you see, with different color. That is the vegetation. That is water. That is urbanization. That is soil, bad land. Now we can difference compared with the corrected images without describing the transformation. So the transformation is necessary to extract the components in which you gonna apply the classification. Okay. Now it's time of the step of transformation is ended, but now is the step of classification. Before classification, you should prepare the training data for classification and the training data for validation. Each classification, you need a validation. I'm gonna creating the training data on in principal component band. I'm creating a region of interest right here, and a new region of interest. I'm already open it. This is it. I'm gonna creating the first one is water, because we have water here. I'm name it water, just for training. I mean training. I will change that colors by blue. As you know, water is in blue. And then digitizing. Region of interest is essential for classification. Here is I'm gonna select in digitizing a polygon higher. Double click to finish the polygon. Here is the water. Double click to finish the polygon. Here, double click to finish the polygon. Here, double click to finish polygon. Here, double click to finish polygon. Also here, I'm gonna zoom a little bit. That is water, but with a suspended matter. Is a well here or a river here. is ça c'est for this just sorry, I'm talking in French. Just for training data, but you should add validation data for each region of interest and zoom out. They add new here, new RUI. I'm calling the now water for validation. Water validation. I'm changing the same color. I'm giving a blue, no problem. But pay attention with the training and validation data. The validation data should be different to training data. Never ever using validated the classification using the same data that you use it in classification. We will see the height, accuracy, and then you gonna misclassify your map. Double click and close. Here's just an example.
So sorry, Ali, here about the number of the samples that you are taking as the training.
Just a wizard.
Yes.
But if you gonna use it field data, you choose the field data. You're gonna collect it from using GPS and collecting data, and then inputting data in ENVI, and to see that the polygon that can be digitized. That's just for example.
And my question is it better now to select them as polygons, or you can, if you have time,
yes,
to select the entire body of the water one time,
yes.
Just one location, and then half of it.
You can do it, but as you know, the classification, there are two type of classification. There are pixel-based classification and object-based classification. Here we use just object-based classification. We know that this area is just water, not like nothing else. But you in your organization, you should do some field or using Google Earth images to input the region of interest area in ENVI, and then to be correct that this area is urban area or soil area or barland area or vegetation area. Just demonstration in ENVI. But you should be careful with the training and validation data during preparation. Okay. Now we're gonna with we still have time, Dr. Amar.
We passed actually. Now we are more than an hour, but I mean
an hour.
Yeah, we finished 1 hour. So if you like to go, as you like.
No, I'm going. It's, we still have just a classification, creating a region, classification and validation.
Please go ahead.
I haven't any problem.
Go ahead.
Now creating a new region, vegetation. Vegetation, just abbreviation, for training. Separating between training and validation. I'm giving the Greek color because vegetation in Greek color. Already I know that is green is vegetation. That is also vegetation. Zoom in, vegetation. That is vegetation. Also that is vegetation. That is vegetation. Now vegetation, creating a new RUI vegetation for validation, but should be different than what you selected first to avoid the misclassification of mistaking the accuracy and the kappa index in the end. Validation, for validation. I give it another color is green also, and then select other polygons here, here. For sure that if you add more and more pixels or more training data, you will be see the best result than if you use it just 2 or 3 points. No. New I'm gonna now add other is urban area. Urban training. I will give it black on black color because urbanization seems to be clear. So I will give it another color here. Urban area. Select that also is urban area may, but pay attention if you be classify your image or using training data, should go through Google Earth. You can enter the region of interest. Be sure that is a correct urban area or something else. Add new. We'll add new. Urban validation. I will be quick. I guess that is correct like that. And then maybe I have already something else. I'm just stopping with this point here, but you can use sol. Maybe I'm finished with sol barland, just land training, and the other colors is red color or something else. This is this is us. Is land. This is us. Is land. I'm gonna finish it with this one. I'm gonna using land validation. Different training data than the other ones. Here, finish it and training here. And here. And here. And then okay. What I'm gonna do now, I'm finished with all land using that I have in my study area, and then export to ship file. I'm gonna export each one. I'm gonna select in training data. I leave it here. Validation. I'm leave validation to validation. I'm gonna name it training data. Choose first the file when I'm gonna choose in saving training data. Then okay, I have just 4 training and training. And then I'm gonna export file to ship file. I'm gonna save in validation data. Validation data. And then okay. And then okay. After that, what I'm gonna do is to classify. Going through to classification. You can use classification workflow or using supervised classification algorithm here, but it's easy to use. Do you want to save a change? No, yes. Limit Ruby here. Already opened. Classification workflow. This is classification workflow is working simply. Input raster data file is principal component analysis is the last one. I'm gonna select in just here the three first band because contain all information, not all bands, just 1 and 2 and 3, and then okay. And then input mask. If you don't want to see the border here, you should be creating a mask and then add it. In this case, I'm not use it. And then next, the use training data. Yes, of course, I have training data. Next, should be add classes on open a class that I have already used for training here is opened directly because I'm opening the training data already. Here is the training data with all water, vegetation, urban area, and land. Here, select the algorithm. We're gonna choose the minimum distance, manifolds, and spectral. We're gonna use just maximum include, but the other classification here to offer other classification. Set probability threshold. I'm not use it, and then next. Here is the map of classification. You can able to save that enable smoothing 3 and you guard it as you want. And then this is the result of my classification is okay. You can export image file as ENVI. Don't forget to select your file when you're gonna use it here. Change the name, classification, Landuse Landcover, Landuse Landcover. Here also you can save as zip file. You can use it. Each class you can import it to ArcGIS or QGIS as vectorial data, as raster data. Name it Landuse Landcover. Any problem? And then finish. Addition exportation, you can use addition exportation just image. Here is the result of classification. This is the result of classification. I don't want to see the threshold or vectorial data, but is this classification. Now what's gonna do is to validate classification. Post classification, rock or buffer zone, convision matrix using ground is going to three post classification step after classification to validate your classification. Here you can see any classes, percentage of land, for example, bar land, urbanization, anything. Ground truth or ground truth. I'm gonna choose in that. Input file is Landuse Landcover. Ground input file. No, it's not this step. Excuse me, is the second one. Should be input file Landuse Landcover. This is the training and validation data. All the first it give you all data as training data. It's not correct to use the same training data as validation data. I'm gonna put that. That is ground truth. That is classification image. Classification image is training data, but ground truth is validation. We have already the validation here. Water, for example, should select water validation with water training and add combination. Vegetation validation and vegetation training. Okay, for classification, for validation here. Ground truth is validation. We have already validation data here. Add combination. Urban validation. What is urban validation? Urban validation training. Maybe that is not valid. Land validation, and I'm gonna add in land validation. I don't know what is going when the urban validation. Maybe that's. We're gonna select urban validation. This is the urban validation. Maybe that is mistake here. I'm not saving the urban validation. I'm using urban. No problem now. But this is the confusion matrix and the percentage rate. Here is the result validation. Will give you the coefficient of kappa and the overall accuracy. Some commission error and omission errors, predictor accuracy, user accuracy here. This is classification is of height coefficient, but is not correct. You should be real. If you said that is the classification is 100 is a 100% overall accuracy is not correct. So
because we used only 3 classes. So
yes, of course,
yeah.
of course. So this is the end of this training session. I hope that you received more information from starting from atmospheric correction to preparation of data to creating a Landuse Landcover map using optical data is Landsat only. And I wish you wish if you to send me an email or contact me anytime.
Thank you very much, Ali. Really, it was comprehensive, and really you put your hands on some kind of exercise we missed. Actually, I don't remember since when I did this, so today it's very nice to refresh with you. We would like to thank Dr. Ali. As I mentioned, he's an assistant professor in the Department of Geology, Faculty of Science in Ibn Zor University, Agadir, Morocco. So in case you have, because we are past the time now, so if you have any questions, and if you are already a member in the SCADAC, you can just send a direct message to Ali, or if you are from outside, you might find the link of the SCADAC under the video, and then so you can join and you can discuss, or you can check even your results in case you did some kind of work about this kind of applications. So thank you very much all of you today for joining us. And we have questions here. Yeah, it's okay. So Ali, you can switch your screen, and we are. Yeah. So we have anything else? You can stop sharing. You can stop sharing.
Ali Lazeri asking that can I use in Snap software with Sentinel-2 to learn? Yes, of course you can use it, but there are many steps in Snap Toolbox. You can find it in in SnapToolbox. Like what? Like for example, SnapToolbox offering just to use it for ESA data. I mean Sentinel-2 or rather Sentinel-1 data. There are other correction you can use it, but start it with SnapToolbox. After that, you can import your data in ENVI, or we can and you can continue the step of this classification in ENVI, and you can just validate your classification in ENVI. Because what? Because SnapToolbox not offering these options to complete your objects in classification Landuse Landcover. It's okay, Ali?
Okay.
Hello, sir. I have a question. Can I ask?
Yes, of course.
First of all, thank you, Dr. Ali and Dr. Umar, for this nice session. Unfortunately, I joined a little late, but I have some question. Actually, nowadays I'm doing the Landuse Landcover classification, historical, 1990 and 2010 and 2020. I use the Aydda software, but the result I'm getting is not very good. So for the training data, can I use actually my area? It is a mountainous area, so there is a lot of noise and like the training simple collection is very difficult. So
But
can I use Google Earth to take this training sample and put it here and then classify the image?
just what you're working with, which data you use radar data?
No, sir. I use the Landsat 5, Landsat 7, and Landsat 8.
You use in optical data, but you are in
Yes,
mountain.
absolutely.
You are in mountain area. What percentage of cloud in this study area? How much percentage of
Flood,
cloud?
cloud.
Ah.
Actually, the images I collected mostly they have 2% or 3% cloud. Some images have 5 to 7%. Yes.
No
As
problem. You can so you haven't any problem. You searching to use training data
Yes, sir.
from Google Earth or from any else or from your field. If you going to field to collect data to confirm what you have as a result, you can do it.
Yes,
You can do it
sir.
as using Google Earth without problem.
Yes, sir. Sir, I have one problem in my area. My area consists is very big, so
sorry, Kash.
yes.
I need to stop record because now we are almost 1.5 an hour. So please, if you
Okay,
have
sir.
anything, you can just directly contact to Dr. and he
Okay.
can answer you
Okay,
with via email or via call
Thank
about
you.
his time. So thank you very
Okay.
much, all of you guys, and it was really joyful to be with all of you
Thank
today.
you, Dr. Amar, for your time.
Thank you. Thank
Thanks.
you very much. Thank you, Si Ali.
Thank
Thank
you,
you,
Dr.
Omar.
Thank you. I would like to take maybe we take the whole screen. Ali, just can you stop sharing, please?
Okay.
Yeah, then we can see the others.
Okay. There it is.
Okay, so I will just. All right. Okay, so now we are all of us here. That's great. So I will just take a shot. So for Yusuf, Yusuf, you want to open your camera? I will just take a screenshot now for all of us. Okay, so all of us here. So 1, 2, 3. Okay. Okay. Thank you very much.
Thank you.
Thank you. Okay.
Thank you, Dr. Mike.
See you later. See you. Bye bye.
See you.
Thank you very much.
Thank you very much.